Welcome back everyone on mahasarkar.co.in. In today's video, we are going to start next article. This article will be one of the basic article for lesson called thermodynamics. The article's title is First Law of Thermodynamics. In a previous video, we have learned about the zeroth law of thermodynamics and thermal equilibrium. Now, in this video, in this article, we are going to study about the heat given to the substance, the impact of that heat produced on the substance, and then what are the parameters that we get at our output that we are going to study here. We know that when we provide heat to any substance like gas, suppose gas is filled in any cylindrical chamber with proper fixed lid, a jar is there with filled which is with gas, and heat is given to the gas, then what will happen? Like exactly pressure cooker, when you give heat to the gas, the kinetic energy of molecule increases. They consistently exert pressure on the wall of that pressure cooker. Okay. Once that pressure is very high, that cannot be bared by that lid of the cooker, then the vessel blows up to release that pressure. So here the same logical things that we are going to apply. So to understand that, few things that we require is, first is the internal energy. The first is internal energy. When we provide heat to the gas, when gas is heated, the kinetic energy of gas molecules is increased. That increased in the kinetic energy termed as internal energy. This is termed as what? Internal energy. So when you heat the gas molecule, then its internal energy is increased. Okay. It is indicated by letter U or delta U, where delta U will initial and final kinetic energy, difference between initial and final kinetic energy. Now suppose we have few things that consider a cylindrical chamber or cylindrical vessel with movable frictionless piston fixed to it, filled with gas. Okay, there is a cylindrical chamber or vessel as shown in the diagram, as you can see, and which is filled with what? Gas. Now we know that the gas molecule will consistently collide on the wall of this piston. Okay, surface on the entire surface area. So if A is the surface area on which that gas molecules are striking, I will say of it is a piston, where the force is actually acting, and that force acting due to momentum of the gas molecule, momentum of molecules. Then we know by definition what is the pressure exerted. Therefore P equal to pressure exerted by molecules. Pressure exerted by molecules, what is the formula? Pressure P is equals to what? Force upon area. Implies force is equals to pressure into area. Say this is equation number 1. Okay. Now, if suppose I say that I have given some heat, so that this was the initial position, say A, not A, say PQ. PQ was the initial position of the piston, and because of the heat, kinetic energy increases, correspondingly momentum will increase, so that pressure is also going to increase. And because of that pressure, that piston slightly move by infinitesimal small distance dx. So I will say let piston moved by or displaced, moved or displaced by small distance dx, displaced by what? Distance dx. Then if dx is the displacement, F must be the force acting on that piston, then what we will say? Work done is equals to what? Force into displacement. This we are familiar with. So dW equal to, force is what? P into A, and this is what? Dx. But as you can see, area into this distance means its volume increases from this one to this one. So this dV, this area into displacement is in, but I will say again, A into dx can be considered as what? Increase in a volume, or instead of calling increase in a volume, we can call it as what? Change in the volume. So I will say it is equals to what? dV. Therefore work done dW equal to P into dV. This will be the basic formula that we will always require to solve numericals. Okay. Now when we discuss this formula with some fixed changes, means suppose initial volume of that cylindrical chamber or vessel was Vi, and that volume changes from Vi to Vf, then how will you find the total work done? So total work done in changing volume from Vi to Vf can be obtained by integrating equation 1. So we are going to find out the total work done by integrating equation 1. So W equal to integral of dW from Vi to Vf. Okay, so we will get finally Vi to Vf of P into dV. This will be the equation number 2, which is very important equation. This work which is done here depends upon the amount of heat what we have given. Now suppose I had given the heat here, heat Q is given. Because of that heat Q, kinetic energy of that gas molecule is increased, kinetic energy is increased. When we say that kinetic energy is increased, then we say that work is done. Correct? Work is done, but at the same time kinetic energy increase means what? Internal energy is also increased. So here if I say that in short, say case 1, first condition here, that if Q is the heat incident on the chamber, heat incident on the material, but no work is done. Work done is what? 0. W is equals to what? 0. Then what is happened only that the gas molecule have used the energy to increase its kinetic energy. They are consistently gaining the kinetic energy and increasing it and striking with more force here. But as that energy is not appropriate, not enough, that piston is not moving. In that case, heat incident is directly used by molecules as internal energy. So if heat is incident but work is not done, then used energy is nothing but what? Internal energy. In that case, I will say Q is equals to what? Delta U. If suppose case 2, you have not given any heat, Q is 0, but still because of large impact of that momentum of the molecules of the gas on the piston moved slightly. In that case, we will say work is done but heat is not given. So work is done against the internal energy. Then I will say it is delta U is equals to what? Minus W. So if I use this logical statement to explain one important thing, that if now we are going to start with the first law of thermodynamics actually. In very short, if Q is the heat given to the substance, heat incident or heat given to the gas, okay, out of that heat, if I say delta U is the internal energy gained by the gas, and after gaining enough amount of internal energy, say some amount of work is also done, so say dW is what? Work done by the gas, or gas here, heat incident to the gas is what? System. So gas, instead of that I can write word system, here also it is what? System. So this much of heat was given and it was used in the two different parts, delta U and delta W. Then by law of conservation of energy, I can write Q is equals to delta U plus delta W, or I can write delta U equal to Q minus W, delta W. These equations here which I have written, these equations are called as first law of thermodynamics. These equations which are marked in red colors are marked as what? First law of thermodynamics. And they completely give one important structure, that they based on what? Law of conservation of energy, or this equation is itself the law of conservation of energy. If you provide certain heat to the system, then system may gain some amount of energy. That gain in the energy by system, we are going to call it as which energy? Internal energy. They gain internal energy for what? To increase the kinetic energy. They increase the kinetic energy so that they gain the momentum. See the sequence. Heat provided, internal energy is gained. Means kinetic energy is increased. Increase in the kinetic energy increased what? Momentum. Increase in the momentum increases what? Pressure. And that pressure will act on that piston so that it will do the work. So in that case, heat provided by us is divided into two important parts. That is, some part of energy is used to gain the internal energy and some part is used to do the work by the system. In that case, we consider Q equal to delta U plus delta W. This equation is called as first law of thermodynamics. Here, if system has done work on the piston against the surrounding, then work done is taken as positive. System has done the work, means because of system the piston is moved, then work is done what? Positive. But sometimes when surrounding excess pressure is there, piston moved inside, so volume decreases. In that case, we consider work is negative. Work done is what? Negative. I hope you understood today's article also. Thanks for watching mahasarkar.co.in. It is one of the most important articles, so read it properly. You can take a screenshot of this. Thank you.